Good morning, boys. Lovely to see so many of you this morning. The Triathlon Club, we had 100 boys at the Triathlon Club this morning. So, being at time, getting up early and getting involved in a Triathlon Club, brilliant. Science, you are so lucky. So lucky. Okay, and I don't think you realise, having practical science from year 3 upwards in science labs and getting a wonderful team that you're going to see today, led by Dr Sialvi. You're very fortunate to have so many opportunities in science. And every single week, I say to the teachers here, it's their job to ignite the passion in their subject. And your juniors teachers do it every day. They might dig deep sometimes to do it every day in the busy term that we're in, but they certainly do it every day. And your science department do it every day of the week. And Dr Sialvi today is going to ignite the passion in you with his team. And it's a massive team effort, okay? And I just want you to think about this before, because we always talk about the school as a team. Before we start today, behind the scenes, Mrs. West has been working extremely hard to support the department behind the scenes. She was in on Saturday, all day Saturday, preparing for this assembly. It's going to blow you away, this assembly. So before we start, we'll say our thank yous at the end. But before we start, let's give Mrs. West a round. You don't want to hear me talk. You've not arrived, boys, to see me. So I'm going to hand over to the science team. So give them a round of applause.
Thank you, Mr. Syme. Welcome everybody to this year's Science Week Assembly, where we hope to once again bring science alive and allow you to really experience the awe and wonder of our wonderful subject. Now, before we begin, who remembers Mr. Symes' epic inertia egg experiment? That was pretty cool, right? Yes? But I think we all wanted to see that raw egg being cracked on Mr. Prentice's head, didn't we? But you know what? That was a great start to the week, and once again, we hope to bring science alive for you and show you some amazing experiments that is going to blow your mind and really captivate your imagination. Now, before we begin, we always start off our assembly talking about the theme. And the theme this year is time, as you can see on the slide. And it's important, actually, because the reason why the theme is time, because this year is the 30th anniversary of the British Science Association, which is amazing, actually, because I didn't know that it was running for such a long time. So it shows to you the importance of science in STEM and about inspiring you all boys and girls about our amazing subject, okay? So we're going to start off with our examples of time in science, and then whilst we're doing that, we would like you to have a little think as well, because we're going to invite some answers from you also. So, my example of time in science is actually related to chemistry. I am a chemist, and chemistry is amazing because you can see the reaction between different substances to make different things. And one of the ways that you can talk about chemistry is the speed at which reactions happen, the rates of reaction. And there's various factors that can affect it. Temperature, concentration, okay, the size of the particles. And actually all of those things are important because you want the speed of the reaction to be at a certain time in a certain way. So hopefully we will demonstrate. I'm going to go first. I will demonstrate first of all the reaction which takes place within this piece of paper. And actually this has been soaked in loads of different types of acids. So we got sulfuric acid, nitric acid. And what that does is add lots of oxygen. Because we know we need oxygen for fire to happen, for things to burn. The more oxygen we can add, the better the reaction. So I just want you to watch this because you've seen this before. Okay? So here we go. Is that pretty cool? Yeah? Yes. We're going to do it again, but this time, stay seated. We would like you to close your eyes because actually you can still see the brightness of that reaction even with your eyes closed. So close your eyes. Close your eyes now.
Oh dear.
That's fine, absolutely fine, good. And then lastly, open your eyes again. So, turn the lights off for this one. Turn the lights off for this one. Hold on a minute, hold on a minute, hold on a minute. Don't let it go slow. Whoa! Mrs. West, would you like to share your example of time in science, please?
Absolutely. So, I love science. I think you might all know that. But for me, the number one most important thing in science is us. It's the humans. We try to make sense of the world around us by using science. We measure things, we observe, we do fair tests, we look at reliability. And for time is just all around us. It's us that have put sense and order to time. We have invented minutes and hours, seconds, months, seasons, centuries, decades. We invented that just to make sense of our environment. And so time will continue long, long, long beyond you and me. That's it.
Mr. French?
Being a biologist, it's a lot of what I think about is life cycles and things. And the year fives will know about the life cycle of a butterfly. So what I was thinking of is butterflies lay their eggs onto leaves, and then they turn into these strange-looking things called caterpillars, and then the caterpillars form a chrysalis. And in there, it completely turns to liquid, and then when the chrysalis hatches, you get a butterfly again. And so the change from a caterpillar to a butterfly is incredible to me, and it's just amazing in the natural world and the way that time and life cycles work.
Brilliant, excellent. Mr. Panting?
Right. For my example, I need a volunteer. Ooh. Laurie, can you come out? Can you come and stand here for me opposite? So, I just need one volunteer.
This one.
Okay, so this one. Brilliant. Laurie, come and stand here. So, the thing that I want to talk about is reaction time. So, just that facing. So, I'm going to throw a ball to Laurie. Laurie, you're hopefully going to catch it. Excellent. Go back. Brilliant. So, reaction time is made up of two things. So this is what we call the stimulus. Alright, so the stimulus, for Laurie, once I start throwing it, the time between him seeing the stimulus and then reacting to move his hand is made up of his reaction time, so his brain registering that the ball is coming towards him, and then the time it takes him to move his hand. So when I throw it up nice and light like this, he's got a lot of time to make a catch. So I start throwing it a little bit flatter, that time reduces, which is all nice and easy, and we always do in games. Now there's something here that Mrs. or Miss Moggs may or may not remember from her A-level PE classes, yeah, which is called Hicks' Law. So Hicks' Law says that the more stimulus we give Laurie, the longer his reaction time will be. So he still needs to catch the rugby ball, but he's going to have a lot of different stimuli coming his way. And it's going to take him longer to process, and we'll see if he's still able to catch the original ball. So Laurie, just looking at the rugby ball. Okay, ready? 1, 2, 3.
Brilliant, excellent, that was fantastic. Okay, so let's have your answers now. Can you describe to us what time means to you in science? We've done lots in science lessons already this week, so let's have some examples. Anu? Absolutely, the human life cycle, and we've spoken about the butterfly life cycle. We can apply that to any living organism. Henry?
The evolution of the earth, like how it's basically magma, spit, and now it's full of cracks and water.
Brilliant example. Evolution of the Earth, our planet. Absolutely phenomenal. Let's have one from here, Charlie. Excellent, really good. Let's have somebody from the front, somebody towards the front. Let's say, yes, go for it.
The time it takes to do something.
course, we know that we have very busy lives and time is of the essence and we need to get things done. Brilliant. These are some really, really good examples. Hands down for a minute because I think we want to now start and do some experiments. Now, for our first experiment actually, it's very, very simple. It's about testing your ability to measure time accurately. Now we know, as I said, we have very busy lives. We're doing lots of things and we want to be able to actually keep on top of things and measure time well. The ability to measure time, I guess, depends on the activity we're doing and our perception of time. So sometimes, when you are engaging in an activity which is really intense, requires a lot of concentration, time seems to move really, really slowly. And then there are other times when we'll be doing something which is really fun. We're watching our favourite movie, playing our video game, or we're in a really exciting lesson and time just flies by. And actually, that's why it makes it difficult sometimes to measure time accurately. But this game is going to test your ability to see who in here is the best at measuring time accurately. So very simple. I'm going to hold an iPad with a timer, and I'm going to count down. So when I say 3, 2, 1, go, the timer will start. I want you to stand up when you think it's 30 seconds. Okay? So when it's 30 seconds, just quietly stand up. And you must do this, everybody's silent. So it works really well. You can use techniques by counting in your head, okay, or just estimating. Are we clear? Yeah. All right, here we go. So,
William, can't look at the clock.
yeah, oh yes, absolutely. No looking at the clocks, this way, towards me. Right, here we go. So, I am ready. So everybody look forwards, please. Look forwards. 3, 2, 1, go. Start it. Fantastic. Wow. Brilliant. Everybody sit down. We're going to have a quick look. Right, we have a winner. Absolutely. Wow, that was so nice. It was peaceful, quiet. I love it. We might do that more often in class. We have a winner. There was one boy who stood up exactly on 30 seconds. Casper. Stand up, hands up. That's it. Stand up, Casper. This Casper, sorry. This Casper here. Brilliant. Round of applause for Casper this side. Well done, Casper. Okay. Brilliant. Excellent. So you can see there, actually, it can work if you are careful, if you are methodical. Absolutely, you can be a very good measure of time. Now, we're going to move on to the next experiment, which is about bags. That's right. So for the next experiment, we're going to be looking at how quickly we do things. Sometimes we're in a rush, we want to get things done. Absolutely. And I just recall back to when I was your age, I was younger, I was hopeless at blowing balloons. Our birthday parties were a nightmare, I could never do it. But actually, everything in life, with practice, you get better. So for this experiment, we're going to see how quickly we do things. So we're going to need 4 volunteers to start off with. So we'll start off at the back and then we'll work our way down. Charlie, come down please. Leon, come down. Ralph, come down. And William, come down. Okay? Those are our 4 stand up. So if you boys want to stand here for me and I'll quickly explain what you are going to do. Right. So we have the ability to exhale and breathe air out of our lungs. That is known as our vital capacity, the volume of air that we can breathe out after taking a breath in. Now, there are a number of ways we can measure this. You will see the different devices here. Okay? You've got a vital capacity bag, you've got a peak flow meter, and you've just got some regular balloons. So there's different ways of measuring that particular ability to exhale the amount of air out of your lungs. So boys, when I say go, I want you to take a deep breath in and then blow as much air out of your lungs as you possibly can in one breath. Are we clear? Okay? Here we go. 3, 2, 1, go. Oh, well done. Round of applause for the boys, please. I'll tell you what, you guys were much better than the year 8s yesterday. They struggled miserably with that task, and actually it's not easy. So I'll put them on the spot there. But you can see there how you can measure the ability to breathe the amount of air that is in your lungs. Now, we thought let's make this a bit bigger and have a competition of all competitions. We're going to now have a competition between staff, and boys. And we're going to see who has the biggest lungs. So sit down for a minute. Right, so here are the instructions. Please listen carefully so everybody's clear. What you are going to do, when I say go, you're going to place your mouth on the opening of the bag and you're going to breathe out as many breaths as you can. And in 30 seconds, hopefully no one's going to faint and collapse on us, but essentially we want to see how much of the bag you can fill with the air that you're breathing out. So 30 seconds, just breathe, breathe, breathe into the bag. Are we ready? 3, 2, 1, go! But if I was to say to you that there is a trick, or not a trick, the science behind doing this in just one breath, the whole bag, do you think I'm telling the truth? Yeah, you can, you really can. And I'm going to demonstrate that now. So essentially what you do is, and everybody needs to watch, because you're going to be doing this in a minute. Alright? You're going to work in pairs this time, so everybody can have a go. You're going to open up the bag, so one person is holding one hand, and the other person is going to open the other hand like this with their thumb and with their finger. The key thing is, you don't want your mouth too close to the bag. Okay? You want it about this distance away. And then, if you do a breath, you can see, you can fill the whole bag. Not too close to the back. Not too close to the back. Not too close to the back. That's enough. That's it. There we go. No, you're too close to the back. You're too close to the back. That's it. From there. Go from there. There you go. Okay. Amazing. Right. Please can everybody put their bags down. Round of applause for our volunteers. Now, another cool thing about these is they become really great rocket launchers. Fantastic. So, let me just explain the science around that. There is science. Obviously, I said you can blow up a 2-meter balloon with just one breath. There is a bit of science behind it. Essentially, when you hold the bag in front of your mouth and you blow a stream of air inside, that creates high pressure because there's fast-moving air. And when you have fast-moving air, it creates low pressure. Okay? Low pressure. And as a result, the air around has high pressure and it just basically follows in and pushes into the bag and fills the whole bag in one place. So you're using the air around you to be able to do that. Okay? Now for our next experiment, we're going to be talking about light and the speed of light. Okay? And that's really appreciate that. Speed of light. So we're talking about speed of light and how light travels and how we can use light to see things. Now we know light travels really, really fast. In fact, it travels at 300 million meters per second. And it travels 1,000,000 times faster than sound. And there are examples in everyday life which actually allow us to see that difference. For example, when you have lightning and thunder, what do you observe when you have lightning and thunder? Yes?
See the lightning before you do it.
Fantastic. You see the lightning first before you hear the thunder. And that's really, really important and allows us to see the difference in the speed. Light is also very important when it comes when it comes to giving us information and our brain being able to process that information, to see things. Now, you've all heard of that saying, seeing is believing, right?
Yeah.
Well, actually, what you think you see and what you actually see, there's a very distinct difference between the two. Now, let me explain. When our senses are constantly taking information and sending that information to our brain, then our brain will process that information and actually allows us to see, or in fact, give us our perception. Sometimes we see things that perhaps are not even there. That's because our brain is programmed to receive the information, and if all of the information is not there, it plugs gaps. And that's when it plays mind tricks with us. And we might see something or an image that perhaps is not the true reflection of what actually is there. And that comes with evolution, because our brain essentially wants to keep us alive. So it needs to have quick reaction times. So it gets information, and if it doesn't have all of the information, it just kind of fills the gaps so it can respond, and we, run away from danger, for example. So that's how we've evolved to come and allow our brain to work in this way. Now this, I've got a set of optical illusions on the board, mind-boggling optical illusions, and it will kind of show you the process that is going on in the back of your brain to be able to allow us to see this. So what I want you to do is just follow the instructions on the board, and hopefully this is going to be really, really cool. So have a look at this one. Hands up if you can see the word optical. Can you see the word illusion?
Yes.
Can you see both?
Yes.
Fantastic, yes you can. So optical is in pink and illusion is in the yellow. Here's another one. Shout out what you read.
Teach.
And? Learn, correct. You can see teach at the top and learn at the bottom, absolutely. What about this one? Look around the board and what do you notice? Yeah, the cogs are moving on the outside. They're not moving, they are still. It's a still image. But because of the information your brain is receiving and the way it's been organized, it appears as if the cogs are moving. Next one. Are all the lines horizontal there? Yes. Oh, yes, no. Okay, interesting. They are all horizontal, but the way the difference in the image and the black and white contrast, it gives you that perception. Next one. Which orange dot is the larger? Well done, Mr. Well done, Alex. Alex has just said that they are the same. In fact, they are the same size. But because of the information around them, fools you in terms of the size and the perception that we get. Next one. Look at that tiny black dot and then blink constantly, and you'll see the others spinning. Yeah? They should be spinning. Can you see the blobs in the corners? They're not there. They're not there. But you can see them in the corners. Straight lines? Honestly, they are. Honestly, they are. The red lines are straight. Marble columns or shadow people? The orange part is the marble columns, and the black part is the shadow people. Yes? Here we go. Hands up if you see a rabbit. Hands up if you see a star. Okay. And this is cool. This is cool. So listen very carefully. I'll give you a moment to really look at this. Look at this picture. So this one is in black and white. Now there is a predator there about to jump out. Can you spot the predator? Yes. Well, you're very good vision if you can. So let me explain. Here in this picture, you are seeing the intensity of light. So the amount of light that is reflected. Now, if I was to put this image in color, not only you get the intensity or the amount of light, you also get the quality of light. So you can get more information. So what's this? There it is. Yes? Now, if I was to go back to the picture, because our brain has processed that information, you'll be able to see it better. There we go. Interesting. Right. This next one is my favorite. Put your filters down for a minute. I will tell you when you're going to use those. So things that are being passed around, just do it sensibly and really listen. This next one is my favorite. Here is a picture of a galaxy. Okay? It's a still picture. Next slide, you're going to get something swirling round. I want you to focus in the central spot for 20 seconds. And then I'm going to switch back to this picture and you're going to see something amazing. Here we go. So concentrate. Filters down, filters down, filters down. Concentrate on the spot in the middle. 20 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. How cool is that? That's cool, right? Okay, so now in the next one, you're going to have to use your filter. Now is the time to look through your filter. Don't take it away from the front of your eyes. You're going to get a sun on the first slide. I want you to shout out the sun.
What's his sun?
Okay. Confusing. What's the background on this? Okay. What about this one? What's the background? Okay. At least we can agree on this one. Okay, do what it says. Do what it says. Okay, sit down. Amazing. Wow. So what was going on there was actually what light was traveling through your filter. If you were holding up a red filter, only red light goes through into your eyes. If you were holding up a green filter, only green light was being be able to go through into your eye. So if you saw anything in red, you could see that font. If you saw something in green, you could see that font. You couldn't see the other one, or not as well. And then if you had any other colour apart from red and green, you would appear as black, because no light is able to get through that filter. And that's really, really fascinating. Okay, for our next experiment, we're going to be doing flour. Ooh, burning things. Okay, so please listen. Sometimes, obviously, we like to do things in Science Week Assembly which you cannot do at home. And this is, from now on, the experiment you cannot do at home without adult supervision, professional supervision. So, believe it or not, burning things, chemical reaction, there are things around your homes that are highly flammable. Highly flammable. And one of those, thank you very much, and one of those things, safety is very important, absolutely. One of those things is flour. Believe it or not, flour is highly flammable. So if I was to burn the flour on here, oh, that's pretty boring, isn't it? Yeah. Pretty boring. Can I give that back to you? Can you please turn it off? So, yeah, I mean, I was expecting an explosion. It didn't really happen. So, fire, we need three things, don't we? The fire triangle. What's the three things we need for the fire triangle? Arthur? Okay, looking at Charlie. From the blowtorch. From the blowtorch. You and Aidan. Heat. Well done, you guys. Excellent. Well done. Everybody, well done. Now we've got all those three things. So what's going on? Why is it not catching on fire? Well, essentially, it's the amount of oxygen available. We know there's oxygen on the outside, so that oxygen is reacting with the flour and is burning in the outside. It's charring the outside. But the oxygen is not getting within the flour, which we need to get that nice explosion. Now this is a real problem for mills, flour mills, because actually, if you have an environment where you create a dust of the flour, and there's lots of oxygen in the air, that can become very, very dangerous. And the whole mill can actually explode. So I thought, let's try and create that environment in a safe way, but to show you, obviously, the effects of it. So what we're going to do now is we're going to puff that flour up into the air with the flame, and hopefully we'll get a really, really nice effect. So, watch very carefully. So, I'm going to try corn flour first. There we go. So, we ready? Pretty cool. There we go. We'll do it again. We'll do it again. Brilliant. Love it. There we go. And finally. Nice. Now we thought we want a bit of an intense explosion. So now we're going to use some icing sugar. So we've got some you see the reaction sugar has? Lots of energy, even this is infectious, isn't it? There we go. So, if we do it with icing sugar now. There we go. There we go. And last but not least. Now, this next experiment is still related to reacting of icing sugar and burning it, but we thought we'd create an even bigger cloud. Now, believe me or not, I did this a couple of days ago. with Mrs. West being present, and she looked at me and she was like, "You're a big kid, aren't you? Literally, you want to just blow the whole thing up." I said, "No, I promise you it's going to be safe." And I did it, and her face was like, "Whoa." So hopefully you're going to have the same reaction, and we're going to do this in a really nice way. Demonstration. Right, lights down for this one then, guys.
Ready?
Okay, here we go. So we'll have a bit of a countdown, okay? Here we go. 3, 2, 1. I felt that. That nearly blew me backwards. That was amazing. Did you do that? Okay, guys. Brilliant. Amazing. That was so much fun. I haven't done that too many times, but every time I do it, it's so thrilling. It's really, really exciting. For our next experiment, we're going to be using a special substance called dry ice. Who's ever dry ice? So, amazing. Now, dry ice is a phenomenal substance because, as we know, it is solid carbon dioxide. We have carbon dioxide in our air. 0.04% of our air is carbon dioxide. If we freeze that down to minus 78 degrees, we can turn that gas into a solid. Okay? Now, dry ice is really special because when you heat it, it goes from a solid straight to a gas. It skips a state. Solid, straight to a gas. Because the melting and boiling points of it are very close. So actually, it doesn't stay in the liquid stage, it just goes straight to a gas. What's that process called when it goes from a solid straight to a gas? Anybody? Solid straight to a gas. Go on, Tom. That's fine. Just start with an S. Yes. Anybody? Go on then. No, ooh, no, almost. Sublimating. Brilliant. Excellent. Sublimation. And that's what happens to dry ice. It sublimates. So I'm going to show you what it actually looks like. So, there it is. These are pellets of dry ice. Now I'm using special gloves because it's extremely cold. You can't handle it without special equipment, and you will be able to handle it, absolutely not. What we're going to do is, we're going to add our dry ice to these containers, and watch this amazing effect.
Whoa!
How cool is that? So you can see it's sublimating, and you can see it sublimating. What do you notice about the carbon dioxide? Where does it go? Where does it go? It goes, shout it out? Down. It doesn't go up into the air, does it? So that shows us, is carbon dioxide heavier or lighter than air? Heavier. It's more dense. That's why it kind of goes towards the bottom. And that effect is really cool because we're going to think about that for the next experiment. And one of the other things you can do with dry ice is you can add them into clothes floss, and it shoots out a stream of CO2. So, it's absolutely safe. It's CO2. We breathe it out. Okay, so you'll see it there, be it coming out of the spout of the floss. Okay, don't touch it. Don't touch it. Good. This is the CO2 you should touch. Okay. Container, really screw the bunch down to the nice tight, and if you hold the spout, it's going to build up lots of pressure. And what I'm going to do? Fly. Here we go. Here's one coming. Woo! experiment, which is going to involve creating a special effect. You've seen movies, right, where they create an effect with like fog or smoke which hovers along the floor. Yes? Like at graveyards and like scenes at graveyards and so forth. Well, believe it or not, many of those scenes are created by using dry ice and smoke machines and so forth. And we're going to create a graveyard effect along the floor, which is really super cool. Now, so, for this to work really well, and how it links to time, is the ability to accelerate or speed up the process of changing state. Now, what we're using now is actually boiling water instead of just tap water. Because, as I said at the start of the assembly, the speed of reaction can be affected by temperature. We've increased the temperature of the water, you can see it bubbling away. Now, when we add the dry ice, that change in state, sublimation, is going to happen even quicker. And the CO2 is going to come out and it's going to fill the floor. Okay? So for this experiment, what we're going to do is we're going to create a circle with a row of boys. It's going to be the front row, okay? And in a minute, I'm going to ask you to come down, not yet. In a minute, I'm going to ask you to come down and you're going to be seated around this bucket of boiling water. And you must stay seated. And when I add the dry ice, it will come to you. You don't have to go to it. Okay? And you can play with it, you can move it out of the way, and so on. But you can't move towards the boiling water because obviously we want to protect you. Okay? So, now, Mr. French, we add, have a look. Have a look very carefully. Mr. French has got the dry ice. He's going to add it slowly. That's good. Just hold it. Stay where you are. No. Mama, stay where you are. Stay where you are. Because if you move the hands around, it's going to actually escape through and it's going to not give you that effect. But look at that. How cool is that? And you see how it stays along the floor. Okay. Now, whilst these guys are here and doing this, I will ask them to come and sit down and we're going to wrap up the assembly shortly. So boys, now, I'll finish with this, which is, we all know how important time is, and using our time is really, really key. To develop skills, to get at something, improve something, we need to spend that effort and time in doing so. If we use our time wisely, we build experiences, like today, we build our knowledge, we build friendships, we build our character. If we use that time in a valuable way, we're more productive. If we waste our time, then actually our return is not going to be as well, or as good. So I want you to really, really think about that and think about everything we've done today in terms of STEM and science and how it relates to everyday life and why it's so important. Thank you very much for listening, everybody. Thank you.
Massive thank you to the science team. I've got to say, I said that to be inspirational, they absolutely were. And Dr Sialvi's absolutely right. You've got to make every minute count in this school, whether you're in a science lesson, history, geography, sports field, drama. Okay, you've got so many passionate staff that will inspire you. You're so fortunate. And this doesn't happen up and down the country, these experiments, okay? You're very lucky that the passion of this team give you these opportunities. So make the most of every single minute today and the next day and your time in the school. So well done. I think we need to give the science department a massive and hopefully, how often you can use that passion and that inspiration that these guys are instilling in you. Go off to explore your science lessons and maybe it's a career in science for you as well.